Okay, so by this point you know how to make a primary amine. So you know there's a couple of methods. So the first method was that you can use the reaction of ammonia with haloalkanes, but we'll learn from that you can get a mixture of primary amines, secondary amines, tertiary amines, and quaternary ammonium salts, unless you use excess ammonia to start off with, or you you're willing to separate your products using fractional distillation, or of course we can use that other method, which is to use the reaction to make a nitrile first and then reduce it using hydrogen. Okay, so this lesson is all about phenylamine. Okay, so phenylamine is what we call an aryl amine. An aryl amine contains an aryl group, which is just basically, it's another word for benzene. Okay, now this is it's a useful starting point for making many other chemicals, and it's made in industry using benzene produced from crude oil. So we get benzene from crude oil, and we can often take benzene and we can make phenylamine from that, and you need to know how to do that. Okay, so let's put a little subtitle: making phenylamine. So it's a couple of steps. So the first step is where we take benzene and we react that with a mixture of concentrated nitric acid and sulfuric acid. Okay, now you've come across that mechanism before. So if you look at the aromatic chemistry topic, you will know this step. All right. So this is step one. That's your first step, yeah? Notice I've put that sulfuric acid there because that acts as a catalyst, yeah? And that's actually involved in the chemical reaction. Now, you do need to know the full mechanism for this, yeah? You need the full mechanism for that in the last topic, which was topic 27. So, I'm only going to write in the step there, but please now go back and have a look at that mechanism. And of course, what we've made here is nitrobenzene, which isn't a phenylamine yet, so we need another step. Okay, so nitrobenzene is reduced to phenylamine using tin and hydrochloric acid as a reducing agent. So that is different to this one. Okay, so people often get confused between these conditions here and the conditions I'm going to write down here. It's still a reducing reaction, but this is using tin. Now the chemical symbol for tin is Sn, and hydrochloric acid. So this is a reduction reaction. Let's have a look at this then. Right, let's balance this equation now. So what you need is, you need 6 hydrogens, okay? We'll put hydrogen square brackets like that, because it's not actually H2, which we're using. The hydrogens come from the hydrochloric acid here. So on the top of this arrow here, there's no tin in the products, so the tin actually acts as a catalyst, and so does some of the HCl as well, okay? And you can do this at room temperature. In other words, you don't need heat. And here we've got a balanced symbol equation, because let's count the number of hydrogens you need in your products here. So we've got two more hydrogens here, and another 4 more here. So 2 add 4, that's 6. That's why you need the 6 H's here. And those 2 options here go into your 2 molecules of water there. You don't need to know the mechanism of this, but you do need to know your reagents and conditions and what you make. Okay. Now you can rewrite this a different way if you want. We can write down a balanced symbol equation. The balanced symbol equation would look like this. Again, we write the square brackets around the hydrogens. Just like you would with the oxidation reaction, actually, in year 12 with alcohols. Okay. So what can happen though, since the reaction's carried out in hydrochloric acid, so we can actually make a salt as well. Okay. So what can happen is this which is produced here, this amine here, this product here, that can actually act as a base, and if we've got acid left over, that's our acid. We know if a base reacts with an acid, you get salt and water. So the salt that we produce, we can write down the chemical formula of that. And in this case, it would be, look what I'm doing here to write down the chemical formula of the salt. I'm looking at my base. And because it's hydrochloric acid, you have a chloride ion here like this. So you can get salt and water produced. Okay, now that kind of causes a bit of a problem, yeah? So what we do is we actually add a strong base to this sodium hydroxide to get our amine back. So we add sodium hydroxide to produce an amine from this. We get a couple of other products as well. We get water and NaCl. That's what I want. Not this. Yeah. So the hydrochloric acid can cause a little bit of a problem in that it can react with the amine produced to produce a salt. However, if we add sodium hydroxide, we can get our amine back. Okay, so we can increase our yield by doing that. Okay, so little short little snippet there, and then next time we'll look at the formation of amides and the economic importance of amines.